Hey everybody, exciting chat today. We're diving into the world of 5G and what's next with Microamp Solutions. David, how are you?
Good. How are you?
Good to see and chat with you again. Really excited for this. You're doing so much innovative work driving the future of 5G. Before that, maybe introduce yourself and a brief overview of Microamp and the problems you're addressing in the industry.
Perfect. Thanks for having me here today. I'm David. I'm CEO and co-founder of Microamp Solutions. We are a deep tech startup, multinational, headquartered in Warsaw, Poland, in Europe, and incorporated in Delaware. So we create multi-gigabit and ultra-low latency 5G millimeter wave networks based on our radios and responding to the need that we are all processing a lot of data nowadays, especially in the times of AI, that we want to analyze a lot of data, take a results, decide. We want to have a reasoning. Everything wants to be automating and all of this stuff, going down with the cost, increasing the processes. And for this, we need to have flexible connectivity, and we need to start working on sending wirelessly gigabits, not only megabits. And Microamp allows this kind of features not only for enterprises, but also for the general citizens. So we work with many mobile network operators that can deploy our networks and allows, let's say, general users like you and me in the most crowded area to like stadiums, for example, to have broad access to the internet. And for example, you can imagine a football match and a very crowded stadium. So we allows you to record the video and upload this video when you are there and when you are watching in the real time the real game.
Yeah, fantastic. So many use cases, particularly in the enterprise. And talk about the 5G landscape where you fit. It's dominated today by lots of giant tech titans. Where do you see yourself as a startup driving innovation and opportunities?
Yeah, so telco market is a little bit stiffed in terms of the innovation with the big guys working there. However, the need for wireless system and the whole ecosystem change a little bit. Now you need to fit with wireless to different, not only different segments of the market, but also different verticals. And it occurs that many of them requires special wireless system optimized for their operations. So everything that you need to have, let's say, small flexible system and upload a lot of data, because mainly the telco industry is used to downloading a lot of data. But now we are uploading a lot of data in a very narrow verticals like ports or many verticals related with the high resolution cameras put everywhere with the AI system to analyzing the video. And sometimes you need to deploy this system very quickly with appropriate software, manage this system, and allows your end devices to upload a lot of data with mobility. And this is the sector when Microamp comes. When you need to have a lot of camera in the certain space, and you need to provide high capacity, wireless capacity with the handover for your solution. And your solution needs to be secure, reliable, very good to maintenance. So when Wi-Fi is not sufficient, then you have Microamp allowing you to upload in the real time a lot of data, because this is the key feature of future communication, zero latency. And with Microamp, it is possible.
Wow, zero latency. That would be quite a dream for a lot of us out there. Uh, Talk about where you see the standards heading. We have millimeter wave. We have various countries putting forward spectrum for enterprise 5G. How do you contribute to those standards and how are they progressing?
Yes, so microamp is working in purely millimeter wave spectrum.
Mhm.
So we believe that higher bands will play a crucial role in the wireless communication on the future. We need to move to the higher bandwidth to provide enough capacity for different segments of the market and to the people. So millimeter wave is first step, and the whole ecosystem is growing, starting from the chipsets, from the chip providers, from the semiconductors, from the antenna and signal processing. So the whole ecosystem is progressing. And the microamp contributing to the release 16, 17, allowing to and advising on introducing new features like integrated access and backhaul, which is quite new implementation in millimeter waves, and especially in millimeter waves provides a lot of let's say benefits, not only for the end users but also for the owners of the infrastructures, because so far we need to put a fiber or Ethernet cable to every radio, but with internet access and backhaul you can just add power supply from your solar system, and that's all. The backhaul communication is going on wirelessly. So microamp is promoting this through the standards, is pushing on the, let's say, whole ecosystem and the whole industry to speed up releasing of the next generation of standard with the completely new features that are not general but can be utilized in a very narrow verticals. Like you have fixed wireless access, you have private networks, but private networks for industry, and you have more than 20 verticals, and each vertical is different, each geography is different, and everyone has different needs. So features like mobility, internet access and backhaul, uplink heavy system, NTN networks, this is something that can really, let's say, solve many challenges, not in general for the whole telco, but for specific segment. And this is something that differs nowadays when we are with the wireless system and like 10 years ago. Because 10 years ago, even 15 years ago, we have big guys providing the solutions for big guys, for mobile network operators. And the solutions were general. Now wireless technology plays completely different role than before, and people are using this not only for sending data wirelessly, but using the wireless system, especially with the edge computing capabilities, to analyze the data, to achieve, let's say, reasoning capabilities, and to build the processes. So this is done as an end-to-end wireless system. Previously, it was separated because wireless system was used only to transfer the data. Now it's completely different role of this system.
Such a big opportunity, and yet still challenges remain. Millimeter wave, as at least here in the U.S., has been a little slow to take off. I think the time is now. But what are those challenges from your perspective, and how do you see yourself, strategically overcoming them?
Yes, so first challenge is the spectrum policy. So we, let's say, advise and encourage every country to allocate at least half gigahertz of the spectrum for millimeter wave for industry, let's call for private networks, so that the enterprises can think, can brainstorm how to build their system for they need. The Germany is the great example for this one. We see a lot of perfect use cases where the needs is not coming directly from the telco providers, but the need is coming directly from the end users, from the enterprises, that they are asking us, hey, we have problems on the production lines with the quality control, and we need to have moving cameras, and each camera is transmitting 200 megabits per second. We have 20 such cameras. With sub-6, it is impossible because we don't have enough bandwidth and multiplication system is complex. Then we are telling, yeah, you have millimeter wave solutions in Germany, 800 megahertz. You can get the local license and you can deploy such system. So spectrum, but in the country, when the spectrum is all allocated through the mobile network operators, this process of inventing new applications, it's a little bit slower because the system integrators needs to be with the big guys, and sometimes for the small POC it's not profitable to ask for this spectrum. And also it is always a question, what's next? If I will be successful with POC, what will be the cost for the commercial deployments? However, many countries understand this and allocates millimeter wave spectrum for this. The second area, of course, is the propagation. That for many, that millimeter wave, I think, has a bad name because of the range of the system. However, we proved as Microamp and our partners many times that in big cities like New York or London, the need for capacity is so high that you have sub-6 base station every 500 meters. So putting millimeter wave every 300 meters is not the big issue, but the change in the capacity is completely different. So we are working for the system architecture to, let's say, achieve full scalability in terms of millimeter waves, to show the partners the good economics for millimeter wave, that increase 10 times in capacity with millimeter wave costs you, let's say, 2 times more, no 10 times more, and costs you less than increasing this capacity as it is with sub-6 networks. So we are working to, let's say, delete or decrease the impact of this bad name because of the short distance. But if you look at the capacity, the short distance doesn't matter because you still need to put a lot of, let's say, base station radio systems. And of course, we are working with our, let's say, semiconductor partners to increase the sensitivity of the system from both sides. I mean, this results in the higher range. So working on this, and also the secret sauce of all, I think, millimeter wave solutions at the moment is algorithms, is signal processing, how to reconstruct the signal in millimeter wave to make the system working in heavy rain. And this was the real challenge like 5 years ago. Now we are able to deploy fixed wireless access solution when to each home or building.
Wow.
We can provide 2 gigabits per second fixed internet connection. And if you have massive rain, it drops up to 1.5 gigabits or up to 1 gigabits per second, but the link is still stable. So this is the magic that lies in the digital signal processing. In many solutions, we are also using the AI, by the way. So AI is also using to improve the quality of millimeter wave signal as a response to the big challenge. And it works because we have many applications that the system is working perfectly, no matter whether it is snow, massive rain, or a sunny day. So this is the way where millimeter wave is going because of this challenge, and because everyone was talking, no, millimeter wave is no go because of rain and because of the short distance. So it is natural that the whole millimeter wave ecosystem and people working on this were focused on this challenge and start to solving this, because the opportunities of solving this problem, of after solving this problem, were huge. Because you can imagine what will happen if you could cover whole United States with millimeter wave coverage. You could use your mobile phone as a computer, because you could always have high wide bandwidth connection with the world. You could use wireless cameras with AI to analyze everything. So connectivity, it is a showstopper for many, let's say, applications, and we need to, and millimeter wave, it is the answer. But you are right, we need to solve many challenges to make it fully scalable worldwide.
Totally. And anyone who's been to a Taylor Swift concert knows that we need far more bandwidth and new approaches to
Yeah.
video and streaming and all kinds of real-time communications. And you're right at the spear, the head of the spear there. You mentioned semiconductor partners, but you have a lot of different collaborations and partnerships and integrations. What sort of value do those partnerships bring, and how do you work together with third parties?
Yeah, so we are working in the collaborations to build the most advanced antenna systems, to be able to use very advanced semiconductor chipsets. The chipsets that previously big guys could afford to deal with. But the semiconductor market and semiconductor ecosystem changed a lot. It means that at the moment we have the whole supply chain mainly focused around the US and the US partners. And each partner is digging in their area, because we can say that we are working at the edge. So millimeter wave is so demanding technology that for antennas you need to use the most, let's say, advanced materials and the most advanced design methods to create the small chipsets. And using these chipsets, you have like using 150 or 200 per antenna. You are putting there properly, you are adding the software to control this system, to apply phase distortion methods, for examples. So the company like Microamp, for the company like Microamp, it is impossible to develop the whole elements. It is impossible for us to focus on the chip design for the antenna, then design the antenna itself, and design the algorithms. But the ecosystem is so great at the moment that we have partners mainly coming from the US working on the small chipsets, really powerful, that combining with our secret source how to build antennas is giving the great results in terms of the long range coverage. And this is a really good question, because RF front ends, it is something that differs Microamp from other, let's say, network equipment providers. So we allow our partners to focus on what they are the best in terms of the RF systems, RF beamformance, and we itself are building software for the phase distortion or gain distortion, and building the antennas with them.
A fantastic opportunity. Really takes a village to put together, these best of breed solutions. So well done there. The other hot topic, of course, these days is sustainability and green tech. And I imagine your solutions, the form factor, the power, the leading edge, technology contributes to that push towards, lower power, smaller, more compact data center and RF interfaces. But tell me, what do you see as the opportunity there to make more green, less impactful, 5G infrastructure?
Absolutely. So this is something that interests especially oil and gas sector or mining
Mm,
sector because they want to achieve climate neutrality for this one. So they are paying a lot of attention about the energy consumption of the systems, how the system is green and something like this. But interesting factor is in 5G millimeter wave, which is combination of millimeter wave technology and 5G standard, is that this technology is really green and this technology is really energy efficient, despite the fact if you are growing with the frequency, your energy efficiency is going down. You can imagine that the 3 gigahertz power amplifier can have efficiency like 50-60% efficiency, which is
mm,
good. The same power amplifier on millimeter wave can have 20% efficiency, which is very bad. So in general, from that perspective, millimeter wave system, they are not energy efficient anymore in
mm,
terms of the system, in terms of the standard approach. But if you look from the other side, and if you start, let's say, counting that sending 1 megabits per second with sub-6 system and compare this to sending 1 megabits with millimeter wave system, gives you the result that millimeter wave system is 50% more energy efficient than sub-6 system.
mm,
So imagine that you have like 500 megabits system sending data wirelessly. So using sub-6 technology, you use the same energy as millimeter wave, but providing you 1 gigabits per second. And this is something that you can easily justify in the Excel files. And this is something that is really convincing for oil and gas sector and mining sector when they are using a lot of cameras because they have autonomous technology. If you want to have something really autonomous, you need to have thousands of cameras. So they usually multiply the sub-6 resources and the power consumption is going up. But with applying millimeter wave system, the same capacity, you have twice less in terms of the energy consumption. So in this approach, millimeter wave, from the theory and practice, it is energy efficient than previous technology. And the other aspect is how we build the systems, how we build the small cells. So for private networks, we want them really small, and the progress and development of the system on chip, like FPGA, ASICs, RF SOCs, and other stuffs, this is the second, let's say, approach that all the industry in general wants to build and design the chips that are less power hungry. And at the moment, we can build a really small millimeter wave small cell, which consumes like nothing in comparison to the big radios for putting somewhere for LTE. Our dream is that we would like to have really small cells, millimeter wave small cells with internet access and backhaul that can be supplied only through the solar system. And this could solve a lot of needs, especially for the continents like Africa or countries like Indonesia, Philippines, that you have a lot of islands and the level of digital society is not huge in these areas, you need to provide, first of all, the internet to people so that they can have access to the world, they can educate, they can have medical consultation online. This is the real needs that we see discussing with many system integrators working in such continents. And still the problem is the costs of the infrastructure. Because if you look at the cost of this infrastructure, the active radios in building the new large deployments is like 20% of the deployments.
Wow.
80%, it is the projects, it is the fiber, because each radio needs to have a fiber. You need to build the electricity, the power supply to this radio to provide someone internet. You need to dig this fiber. It takes a lot of time and a lot of money. So having the radios like this really wireless small cells that you put it and it works, and wireless backhaul through IAB, it is something that Microamp is targeting, and I hope we will be able to provide that kind of feature soon.
Fantastic. Well, it's really exciting time for Microamp. As far as the future holds, I mean, how do you see yourself continuing to innovate, staying at the bleeding edge of technology, particularly when you have, companies in this space, no secret, like Huawei or ZTE and others almost giving away their technology, and yet you're managing to thrive in this space. What's your secret there?
So we are trying to focus on the very specific, because still big guys, even except Huawei and ZTE, they are like veteran, let me call it veteran vendor suppliers. They are still focused on providing the general wireless system. Despite the fact they are targeting private networks and some verticals, the solution is general. We are trying to build and to grow on the specific niche. One of this niche is uplink heavy system that, in combination with the high resolution cameras and the flexible system, that you can have a small starter kit for like 80, 90K forever permanent license with the high resolution cameras. We are touching different segments and growing on this niche. Another important factor is that especially in US, many US chip company wants to enter the telco market, and they are looking for partnerships. So we are creating a really giant partnership with the giant partners from the semiconductor industry, and we, let's say, are treating Microamp as a gate and helping them to enter this market. And with the same time, we are acquiring some part of the market. So the ecosystem is changing, and partnerships for us is the key features to establish, let's say, the new rules on the telco market, because veteran vendor suppliers, they are focused on wireless system, but they are not perfect from the semiconductor level. But small companies like Microamp is good in wireless system, but having the strong semiconductor partners that wants to play the role itself give us enormous advantages and allows us to not only compete with these veteran vendor suppliers with a strong partnerships, but also enter to the big deals with the biggest mobile network operators in the world, with the completely new business models, with the completely new margins, because they have still the big name, the big partners behind us or with us, but the level of company they are talking to and the services and the solutions are built in the completely different business model with the completely different costs from their perspective and completely different flexibility. So this is something new on the market, and it works. So this is the good thing for us, that for the biggest MNOs and the most innovative MNOs, it works. So we have innovative solution plus still good credibility with the partners. So partnerships in the telco market, it is still critical and key to success.
Well, fantastic. I really can't wait to see how your story unfolds onwards and upwards. So we're entering the summer month, beautiful time of the year in Poland, as well as here in Boston. We're a little similar. We have tough winters and amazing summers. What are you looking forward to? Hopefully a little bit of rest and relaxation as well as hard work.
Yeah, perfect.
Thank you so much for joining, David. Really intrigued. Can't wait to see you around maybe one of the industry events, Mo World Congress or other places. But thanks for joining.
Absolutely. Thank you, Ivan.
Thanks everyone. Thanks.